Bismillahirrahmanirrahim. Assalamu alaikum dear students. I welcome you to the next section of the Linux lecture series. Today we are going to talk about security in Linux. So before we start playing with the terminal, let's have a brief overview of the theoretical concepts. Students, Linux implements security using the AAA architecture: authentication, authorization, and accountability. Let's see what are these things. Authentication. Authentication is also said as system security. By authentication or system security, I mean who all are allowed to access the system. Anyone, even a program, who wants to access a Linux machine must have a proper user account on it. As we have seen in previous sessions, that to log in on a Linux system, one must have an entry in the local user database file, and that is we know the famous @cpasswd file, and of course having entries in @cshadow, @cgroup, and @cgshadow as well. Once a user is authenticated, he or she successfully enters the system, and then the next level is the authorization. By authorization, I mean the authority of a user to perform various operations. Whenever you successfully log in inside a system, you normally perform some read, write, or execute operations on different files and directories inside the system. Or you may say that you access various resources of the system. So what we are going to talk about, the two levels which we are going to talk about are the directory level authorization and the file level authorization. Why I am taking directories as a separate level? Because directories are a little bit dealt in a different way as compared to the rest of the files. The third A is the accountability. By accountability, I mean after a user has been successfully authenticated by giving his username and password, and he has performed various operations on various objects. After checking the proper authority of that user, all these steps which that user has taken are written somewhere in some file, and that is known as accountability. I mean to say the footprint of the user is recorded for later forensic usage. As far as the authentication part is concerned, we have seen that part in the user management. Today we will be interested in the authorization part, how Linux manage checking the authority of an already logged in user when he tries to access various files and directories in the system. Sometime later, gentlemen, inshallah, we will of course talk about the accountability as well. That is the footprint of a user which are recorded by the operating system kernel. Right, gentlemen, I have many times I have said that everything in Unix is a file. May it be a speaker, may it be a keyboard, a VDU, a network card, whatever it is. With this, I mean every resource in Unix can be treated as a file. So as far as the file security is concerned, file security in Unix is concerned, uh, I may say that what can be done to a file? What can be done to a file? With this I mean the permissions. And the permissions, as we all know, are the read permissions, the write permissions, and the execute permission. So there is another question that arises in mind related to file security, and that is by whom it can be done. Users and groups, which we have already seen. And just to recall, we have users or owner, let me say user owner, which is represented by a U. Then we have the group owner, which is represented by a G, and then others. By other means rest of the world. Anyone who is not user owner or group owner, he falls under this category, the rest of the world. Right, as far as the permissions are concerned, gentlemen, permission on files and directories means something different. Let me explain these to you. Permissions on files. Versus permissions on directories. Okay, if you have read permission on a file, that means you can read the contents of the file with the help of the cat or the less or the more or the head and such kind of programs. So these are the read permissions. Simple. Having write permission on a file means you can edit the contents of the file using editors like Vim, Pico, Nano, or gedit, or maybe some other. Finally, the execute permission on a file means you can execute the file as a program. Normally these permissions are set only of the executable programs. We say normally a.out. So this file must have its execute permission set if you want to execute it like this. In case of directories, if you have read permission on a directory, I assume that you have gone through the lecture of the different file types in Unix. From that, let me recall that a directory is a file which is just having entries inside it. For each file, one entry per file, and the entry contains normally the inode number and the name. So each entry in a directory contains an inode number and a name. So to read a directory means you can read an entry or read all the entries of that directory. So the ls program can operate on a directory only if you have read permission on that directory. Write permissions on a directory means that you can create new entries in that directory. By creating new entries in that directory, I mean you can you, you can use mkdir to create a subdirectory within that directory. You can use let's suppose touch to create a file in that directory. You can use cp to copy a file in that directory, or you can even use vim to create a file in that directory. You can delete existing directory entries using rmdir, using rm, or maybe mv. So by write permission on a directory, I mean you can create entries in that directory. You can remove entries from that directory. As far as execute permissions on a directory, this is a bit tricky. Try to understand it properly. Having execute permission on a directory means you can cd in that directory. You can use the cd command and get inside that directory. So without execute permissions on a directory, the read-write permissions are meaningless, because to read a directory you need to get inside that directory. Similarly, to write in a directory you need to get inside that directory. So if you have permissions like read write dash on a directory, or dash write dash on a directory, or read dash dash on a directory, they all are meaningless. This permission on a directory means nothing. You cannot read or write that directory having this permission. So the minimum permission on a directory which means something is dash dash x. This directory, this permission on a directory means you can cd in that directory. Now along with this x, if you have a read permission, that means you can read that directory, and if you have a write permission, that means you can write in that directory. So after understanding all this, gentlemen, let me say that we can display the permissions. You all must have done this. Display permissions on file and directories by using the ls-l command. Let me move on to the terminal and start showing you what I'm saying right now. ls-l. Okay, so let me this is a file. Okay, let's see the permissions on this file, prog3.c. Here you can see 10 characters, including the first dash. The first dash is the type of the file. Here it is a dash, that means a regular file. Then you have 3 characters, read, write, dash. Then 3 characters, read, write, dash. And then 3 characters, read, dash, dash. Let me show you these characters over here. So this basically represents the file type, as we have seen in some previous session. This represents the regular file. D represents the directory. L is for a symbolic link. P is a named pipe. C is for character special file. B is for block file, and S is for socket. So these are the 7 file types. You can find any one of these characters over here. These are the permissions for the user owner. These are the permissions for group owner, and these are the permissions for others. Whenever you try to access a file, it first checks if you are the owner of the file. If you are the owner of the file, these permissions will apply. And if you are not the owner of the file, it will be checked that are you the group owner of the file? If yes, then these permissions will apply. If you are neither the user owner nor the group owner, then these permissions will apply. To maintain the file type and permissions, Unix system use a 16-bit structure. Let me draw it for you for better understanding. 4 bits are kept for determining the type of the file. Then we have 3 special bits. These are known as the special permission bits. I will discuss them in the end. Then we have 3 bits. Then we have 3 bits. And then we have 3 bits. 3 bits, 3 bits, 3 bits. These are the 3 bits again, and these are the 4 bits. Total 16 bits. So these 3 bits represents the user owner of the file. This is for the group owner of the file, and finally this is for the others. So if we have something like this, that means that the user owner has read and write permissions, the group owner has read and write permissions, and others have the read permissions. Okay. So before I start playing with changing of the permissions, let me briefly tell you the ownership of a file or a directory. The owner of the file is the person who is the owner of the program that created the file. For example, if user Arif executed Vim program to create a file prog1.c, then the owner of the file is, of course, Arif. Similarly, if user Kakamana executed GCC program to create a file a.out, then the owner of the a.out file is set to Kakamana. And the same applies to the group as well. The group of the file is the primary group of the owner of the file. So this is how the owners are set by creator programs. Whoever runs the program owns these programs, and they owns the file that are created by these programs. But later on you can change the ownership. You can change the ownership by chown command. You can use chown command to change the ownership of a file. For example, let's suppose you say user 1 and file 1. So that means change the ownership of file 1 to user 1. Similarly, if I say ch group grp, group 1, file 1, that means change the ownership, group ownership of file 1 to group 1. And remember, you can execute these programs only if you are the owner of this file, as well as you own this administrative responsibilities of this user as well. And similarly, if you want to change the group of this file, you need to own this group as well. So better is that whenever you are doing these, you need to be root. So let me show you this on the terminal for a little bit clearer understanding. Let me use to DDD. Let me RM everything from here. So I am Arif, and my present working directory is DDD, and let me say I create a file F1 and I make a directory D1. Okay, so the owner and group of this directory is Arif. Let me change it ch on, okay, let me say Kaka Manna F1. So operation is not permitted, so let me be root, or let me try using sudo. So you see the owner Kakamana is of file F1. The ownership of F1 has been changed. Okay, so after understanding a bit about the ownership, let's talk about the permission part now. Let me move back again. Let me open another board. Let me take again the white color, my favorite. So changing permissions. Before I go into the board, let me say that in order to change permissions, the command which you are going to use is chmod, and you give a mode argument to it, and over here you give the file or the directory name. This mode part can be given in two ways. One is the symbolic way and the other is the octal way. Let's talk about the symbolic way first. In the symbolic way, you say three things: who, the operator, and the permissions. You can specify U, G, O, or A in the who part. By who I mean for whom you want to change the permissions. You want to change the permissions for the user owner of the file. You want to change permission for the group owner. You want to change permission for the others only, or you want to change permissions for all. If you want to just add some permission, you use plus. If you want to remove some permission, you use minus. And if you want to assign a specific part of the permission, you use W. And the permissions are represented by R for read, W for write, and X for execute. That means if in the mode part, in this part, I say, let's suppose chmod U is equal to RWX F1. So this means change the user owner permissions of file F1 and make them read, write, execute, and leave the group and the other permissions as they are. If I say G is equal to W, that means I'm saying that change the group part of permissions of F1 to write. Read and execute should be set to 0. That is, the group members can only write this file. They cannot read or execute. And let the user owner and the other permissions as they are. I can say, let's suppose O plus R. By this I means give others the read permissions and leave the rest of the permission as they are. I can say O minus W. This means remove write permissions from others and leave rest of the permissions as they are. Similarly, I can say, let's suppose, let me write again, chmod A plus R F1. That means give read permissions to all, to the owner, to the group, to the others, and leave the rest as they are. I can say like U is equal to write, read and write. At the same time I want group is equal to read and others is equal to read. So I'm saying that change the owner permission to read write, the group permissions to read only, and the other permission to read only. Let's check this out on the terminal for clear understanding. Right, let me take one file and keep changing the permission and show you one after another. Okay, let me use ls-l. I don't want to see that. Okay, I say chmod u is equal to read write execute f1. Okay, this is owned by Kakamanna. So let me be the owner again. Sudo chown Arif f1, and let me repeat this command, and now you can see the permission on f1. Previous permission on f1 by the user are read write dash, which are now read write execute. The rest of the permissions are unchanged. Read write dash, read write dash, read dash dash, read dash dash. If I want to say that the owner should have read write permission, the group should have suppose read write permission, and others should have read permission only for f1. So now all the permissions are changed. You see, if I want to say chmod take permissions from others, take read permissions from others, and let the remaining permissions as they are. So others have read permissions over here, and we have taken the read permissions from others over here. So this is how the symbolic way works. And there is another way that is known as the octal way of doing things. So most of the people prefer octal way. Okay, so let's see how the octal way works. Changing permissions. Octal way now. Remember, let me draw again the 16-bit pattern. The 4 bits for type, 3 special bits, 3 bits for user, 3 for group, and 3 for others. So this portion is read, write, execute for others. This is for read, write, execute for the group. This is for read, write, execute for the owner. So these are the 3. These are the 9 bits which I am interested in right now. So this is the faster way of changing permissions, the octal way is. Remember, when using octal codes, all the permissions are changed entirely. You cannot add or remove individual permissions as you have done in a symbolic way. For example, let me give you an example. I can say chmod 644 f1. By 644 I means, let me make it something like this. This is for the user. This is for the group, and these are for others. For user I means read, write, execute, and if I write 6 in binary way, it is 110. So that means the owner has read and write permissions. For the group, you see 4 can be written like this. So that means group members have read only permissions. And similarly for others, again we have this. So if you don't know about the octal way of counting, let me review it for you. We can write counting in binary in 3 bits: 0, 1, 2, 3, 4, 5, 6, and 7. So in octal I can say 0, 1, 2, 3, 4, 5, 6, and 7, and the permissions are set to 3 dashes, execute only, write only, let me write only, and for 3 I mean write and execute, read only, read and execute, read write dash, and read write execute. I hope I have done them correctly. So if you know the octal way of counting, you can easily use these. For example, let me use some example commands. I can say chmod 777 on F1. That means give all sort of permissions, read write execute, and read write execute on F1. I can say chmod 711 on prog1, suppose. Read write execute for the owner, and execute only for group and others. So let's try this on the shell. Okay, so F1 has these permissions. I say chmod 777 F1. You see all permissions are changed. I say chmod 660 660 F1 ls -l. So that means this 6 means read write for the owner, and you see read write for the owner over here. This 6 means read write for the group, and you see read write for the group. And this 0 means nothing for others, and you see these 3 dashes over here. So this was the octal way of setting the permissions. I personally prefer the octal way. Now gentlemen, a bit about how the default permissions are set. The way we have seen that once you create a program, the owner of the program is set, and you can change the owner of that file later on. And now we have seen that how we can change the permissions of a program, but how the permissions of a program are initially set. Let's suppose, let me show you. I say touch F2. You see the permission on F2 are read write dash, and read text dash. And once I created this D1 directory, the permission on the directory were read write execute, and read dash execute. So we need to understand how the default permissions are set when a new file or directory is created. Well, in this case as well, the permission bits are set by the creating programs. Here there is another concept of umask. Every program has a umask value associated with it, which is normally inherited after a fork. You can see this umask by giving the umask command, and if you want to see it in the symbolic way, so you can use a -s with the umask. So this is the umask value for s, and this is the umask value for the octal way. I am a regular user. The regular user normally have a umask of 0002, and if I am a root, let me be root. The root have a umask value of 0022 normally. Let me move here and try to explain how the default permissions are set. Okay, so default permissions. So now we are going to see the default permissions. As far as the files are concerned, gentlemen, whenever you create a file, the program that creates a file normally use a system call that is open or create, and to the open call, the third argument is normally a value that is mode. And once a file is created using this system call, the resulting permissions on that file are mod, bitwise or, bitwise and not of umask. Let me rub it and do it again. The resulting permissions are mod and not of umask. Okay, so what is this mod value? For the Vim or the touch program, the mod values is 0666. And what is this umask value? This is the value which we have just seen. Every shell program has its umask, which is normally set to 0002, let's suppose, for a regular user. So what are the resultant permissions on the file? The resultant permissions on the file are 0666 and not of umask 0002, which is 0666 and 7775, which is 0664, which means these three means read, write, dash, read, write, dash, and read, dash, dash. So we can confirm this over here. The permissions on F1 are read, write, dash, and the mask value is changed. Let me check the umask, which is 0002. Let me touch F2 and let me do ls-lf2. So the permissions are read, write, dash, and read, dash, dash. Read, write, dash, and read, dash, dash. Okay, let me change the umask. Let me give it a umask of, let's suppose, 323. Umask of 323, and now I touch F3, ls-lf3. Can anybody tell me what will be the resulting permission on F3? Okay, let's try to compute them. Let's compute them with a different color. Let me use red this time. So the permissions will be mod and not of umask. We know the mod for the touch program is 0666, and the umask which we have set for the current program is 323, is 0323. So now if we use this, then 0666 and not of 0323 is of course 7454, which becomes 0444, I think. So read dash dash, read dash dash, read dash dash. If the umask is 323 and the mod of the touch program is 666, the resultant permissions should be something like this. Let's check out. Let me press enter. So you see read dash dash, and read dash dash. So this is good. So this is about the files. Let's see about the directories as well. Permissions for the directories. Default permissions. For directories, we have the system call that is used to create a directory is mkdir dash and mode. Here comes the path of that, and the permissions which come up are mod and not of umask Up till here it is the same as of the files, and 0777. For the mkdir command, the default mode that mkdir uses 0777. So let's check out now. Right now the umask is 323, and I use mkdir D5, assuming that D5 do not exist, and I want to check out the permissions on D5. So the umask is 323. The mode as such, let me change color. The mode is, we know that 0777 and not of 0323 and 0777. So not of 0323 is 7, 4, 5 and 4. And if we use this ampersand, we come up with 7454, and we come up with 0 and a 454. So a 454 maps to read dash dash, a read dash execute 5, and a read dash dash. 4 means 100, which is mapping onto this, and 5 means 101, which is mapping to this, and 4 again means 100, which is mapping to this. So these should be the permissions. So let me check out. The permissions on D5 are read dash dash, read dash X, and read dash dash. Let me highlight it for you. So gentlemen, this is how the permissions, default permissions are set. I will strongly recommend that you should practice them a lot. Finally, if you want that, you should mention the permissions on the newly created directory by yourself. You can use mkdir -m, let's suppose 777 and D6 ls-l. So you see the permissions on directory 6 are as you have mentioned over here with the -m option. So using -m option, you can specify that these should be the permissions. Similarly, there is another option that you can use the CP, that is -p. -p means preserve permission. Once you copy a file, the permissions on the destination file are changed. So if you use -p options, they will be preserved. Let me show you one more thing. Okay. Once you're copying a file, let's suppose you are copying a file from my present working directory, my home directory D1, then D2, then D3, then D4, and then there is a file f1.txt, and I want to copy it to my home directory in D7 and D8, let's suppose. So this CP will succeed only if you have execute permission on all these directories till the final file, at least execute permission on all, and on this D4 you must have read permissions. Above this D4 you should have execute permission at least, and on this D4 you should have read permission so that you can read the contents of this file, read as well as execute. And on this file you should have again read permissions at least. Over here on these two directories you should have at least execute permissions, and on D8 directory you should have at least execute and write permissions. Only then you will be able to create a file inside D8. So please map these concepts of permissions in your mind while using the CP, MV and RM and other commands. So that is all about today's session, gentlemen. Hope it was informative. I request you to please do a lot of practice of the file permissions and the directory permissions, so that you should have very fair idea how Unix implements security in it using the files and the directories permissions. Allah Hafiz to you all. See you soon again in the next session. जहां का सबात है तुम ही से मुजाहिदो जहां